Thank you for watching Lion's ORAN demo video. In this session, we like to cover some third-party validations of Lion's Ranathan ORU and ORAN end-to-end solutions. All these tests are conducted in trusted independent labs with professional personnel and fine-tuned testing equipment or products. In this video, you can get an objective and vivid view of Lion's ORAN products in addition to specifications. Lion's Technologies headquarters is in Hsinchu, Taiwan. We dedicate all our resources in development, manufacturing, marketing, sales and customer support of mobile wireless base station and RF technologies. Currently, Lion's 5G ORAN FR1 end-to-end gNB solution is comprised of OCU, ODU NFV kit, front-haul gateway, outdoor ORU, and indoor ORU. In the past year, as a member of ORAN Alliance and Telecom Infra Project, Lions is fortunate to participate multiple third-party validation programs held by industry and government organizations. These third-party programs not only verify conformance of Lion's product, but also push the performance of Lion's products. Here are some examples of the events we joined. Global Plugfest 2021 Fall and 2022 Spring by ORAN Alliance, TIP Open RAN end-to-end test by TIP Lab, Taiwan, and 5G Open Network Integration and Validation Program by National Development Council of Taiwan Government. All these tests are based on ORAN standards. This page overview the 5 selected validations in this demo video. On the screen, you can see a simplified functional architecture of ORAN, including network elements and open interfaces. The yellow blocks are main ORAN elements, including ODU, OCU, front-haul gateway, and ORU. On the upper part is management functions of ORAN, including SMO and different RAN intelligent controllers, connecting to ORAN main network elements via different open interfaces. While the blue block on the right is 5G core network. And finally, the mobile phone on the left is 5G user equipment. This architecture depicts the framework of ORAN. The first part, third-party validation, is related to ORU and front-haul gateway. It is mainly for functions of open front-haul. Test A covers user plane and control plane of OFH, and Test B is for synchronization plane of OFH. The second part is for end-to-end behavior of ORAN, EQ, the yellow blocks in the architecture. These 5 tests are just small part of all the third-party validation and are selected to various aspects of Lion's solution. Let's check them in following pages. Lions assigns below models for the validations. RS-8600 Indoor ORU is the major radio unit sending and receiving radio signal to or from user equipment. An XG-8600 front-haul gateway extends coverage of open front-haul and provide clock source via its GPS function. The baseband unit is implemented by GS-8600 OCU and ODU NFV kit, including application software and hardware acceleration card. These 3 items are the main DUT device under test in the demo. The validations in this demo are hosted in Taiwan. Testing standards are based on ORAN documents, TIP documents, or functions of professional testing tools. The A, C, and D tests are hosted by ORI ORAN Testing and Integration Center. And B item, for synchronization plane of open front-haul, is staged at TIP Community Lab in Taiwan. The last item, E, is conducted at research arm of Taiwan's top mobile carrier, Telecommunication Lab of Chuo Telecom, and implemented under commercial 5G testing software and core networks environment. The purpose of Test A is to verify the ORAN conformance of OFH user and control plane. We have ORU and front-haul gateway as DUT. Test setup is arranged using keysight DU SIM, SA, GA, and clock source according to downlink or uplink configuration. The purpose of 3.2.5.1.1 test is to ensure the radio can meet the most basic uplink and downlink requirements for O-RAN fronthaul using a TDD signal. The modulation analysis diagrams are attached to verify the compliance. The purpose of 3.2.5.1.2 test is to ensure the radio can meet the extended uplink and downlink requirements for O-RAN fronthaul using a TDD signal. Again, the modulation analysis diagrams are attached to confirm the compliance. The 3.2.3.4.1 test validates that the timing on the air interface is according to requirements specified in the CUS specification when the C-plane and the U-plane messages are received within the ORU's reception windows. The modulation analysis diagrams are attached too. The result ensures the conformance of Lion's open fronthaul. The purpose of this test is to ensure the radio can accurately interpret C-plane resource allocation messages with the RB parameter set, transfer U-plane data into the correct resource blocks, and transmit this data accurately in the downlink and interpret and capture the correct resource blocks in the uplink with the RB parameter set. The modulation diagrams are displayed on the bottom right concern to show the conformance. The last item in a test case will validate that the transmission of the U-plane data in uplink direction are transmitted correctly by the ORU within its transmission window. Again, the modulation diagrams show O-RAN conformance of Lion's ORU. The next test goes to synchronization plane of ORU through IEEE 1588v2. The test setup simulates two fronthaul gateways receive clock signal via IEEE 1588v2 packet from the same clock source, E.Q, BBU. The original clock signal is from the GPS antenna of the master clock source. Agilent oscilloscope is applied to measure the phase difference. The purpose is to verify that the IEEE 1588v2 clock synchronization accuracy of the fronthaul gateways meets the requirements. The criteria of phase difference should be smaller than ±1 microsecond. Data from the oscilloscope reveals the phase difference is 18 nanosecond, which is way smaller than the criteria. Thus, synchronization capability of fronthaul gateway can meet O-RAN requirement. Synchronization can be achieved by two fronthaul gateways receiving GPS signal independently and respectively. The setup works with Druid 5G core network and Samsung S21 5G phone. Phase difference of the two cells is measured by the Agilent oscilloscope connecting to the two fronthaul gateway. The threshold of phase difference is still ±1 microsecond. Measurement results showing difference is smaller than 1 microsecond imply compliance to O-RAN requirement. Data from the oscilloscope reveals the phase difference is -162 nanosecond, which is smaller than the threshold. Therefore, synchronization via independent GPS of fronthaul gateway can meet O-RAN requirement. The test setup is a single-cell scenario with stationary emulated UE placed in different radio conditions. The UE is gradually placed in different radio conditions from excellent, cell center, to poor, cell edge coverage limited cell edge in case of single-cell scenario. Keysight 5G core network simulator and UE simulator are used in this case. Bidirectional throughput of UE are recorded to show end-to-end performance difference at different UE location in a cell. The result shows downlink throughput can hit around 800 megabit per second at excellent, good, and fair radio conditions. Uplink throughput can stay in plateau, around 255 megabit per second under excellent and good radio. However, downlink speed drops to 533 megabit per second at cell edge, and uplink speed fall to around 170 and 155 megabit per second at fair radio condition and cell edge, respectively. Furthermore, you can see the downlink speed keeps stable even at cell edge where UE RSRP is -97.6 dBm. This case demonstrates end-to-end performance of Lion's gNB at different location of a cell. This case demonstrate inter-OCU mobility of UE via XN interface. In standalone mode, the test setup consists of two 5G cells, each one associated with a different Lion's ODU and OCU connected to same Keysight 5G core network simulator. The test environment shall have single UE. A Mediac-based 5G phone with engineering mode is used as UE here. When the UE move from coverage of one cell to another cell, shown on the left side of the setup, the first OCU will hand over the UE to the second OCU to enable the mobility. The bottom part show the result of this case. The bottom left image displays two cells can be detected on UE simultaneous in the mobility process. The next image in middle bottom show ping continues receiving echo in the process, without connection drop or significant delay. And finally, the bottom right image is the log of OCU listing the detailed steps of the mobility process. A UE moving from one cell to another cell can enable mobility operation between OCU by XN interface. All behaviors follows the definition of ORAN standard. This setup requires Lion's ORAN end-to-end solution connect to 5G core network from different vendors to a real 5G UE. Samsung S21 5G phone acts as UE in the test. To pass the test, RAN must connect to multiple 5G core networks in a reasonable time. The baseline 5G core network are from Cisco, Ericsson, Nokia, and QCT. Then, bidirectional throughput of end-to-end is recorded without optimization, due to time limit. This case is conducted in telecommunication lab of Chuhua Telecom, who is the biggest mobile carrier in Taiwan. Lion's end-to-end ORAN solution is tested to finish all 5G core network connection, from registration to ciphering of radio link, from the 4 core network vendors. As there is no time for optimization, throughput of end-to-end from UE to 5G core network varies. However, Lions can achieve uplink 889 megabit per second and downlink 151 megabit per second with one 5G core network. The figures are close to performance of Lion's ORAN end-to-end configuration with Keysight simulators. One 5G core network case is not complete due to configuration issues. On the other hand, round-trip latency can be registered around 15 nanoseconds, without any optimization. Overall, the case justify NG interface of Lion's OCU can easily connect to commercial 5G core network products with ease. We introduce 5 testing cases covering static and dynamic characters of Lion's ORAN gNB. All these cases are recorded by professional personnel in trusted third-party organizations. We have testing results from ORAN Testing and Integration Center, TIP Community Lab, Telecommunication Lab of a mobile carrier, and some governments. These third-party verification provide objective view of capability of Lion's ORAN products. Secondly, we can read from the report that all these validations adopt professional testing equipment from Keysight, Agilent and top brand 5G products. All these products are standards aligned and compliant, so successfully set up and implementation of the test imply Lion's ORAN products are ORAN and industry standards compliant. All the testing results complement specifications in datasheet. Lastly, Lions collects many data and figures in these third-party validations. In addition to confirm conformance of standards using the data, Lions can also set up some baseline number for different dimension of RAN performances. It can be helpful for debugging and root cause investigating in future service jobs. Moreover, comparisons of data under different scenarios inspires Lions to plan possible way to optimize performance. The cases in this demo are just small part of all the third-party validation we have. You can contact us to get complete testing list or further information. Thank you for watching the video. We hope the introduction help you see the other side of Lion's product and validation of ORAN architecture. Please access Lion's website for more information.